Transpose of the cofactor matrix will give the adjoint. If you divide the adjoint of a matrix divided by its own inverse, first find out AB and adjoint of AB and inverse of AB. Then find inverse of A and inverse of B, multiply B inverse and A inverse, LHS is equal to RHS. You know, inverse of A is A inverse is equal to 1 over determinant of A into adjoint of A. Once if you know how to find the inverse of 3 rows and 3 columns, easily you can solve the problems on simultaneous equations. Hello dear students, welcome to this session of mathematics class. I am Mr. Niranjan, the faculty of mathematics, Vidhyaashram PU College, the Temple of Excellence. Now, in the previous class, I have discussed regarding how to find the adjoint of 2 rows 2 column and 3 rows 3 column. Now by knowing the adjoint, we will proceed to the next concept, that is the inverse. Now in this session, I am going to discuss regarding how to find the inverse of 2 rows 2 column matrix and 3 rows 3 column matrix, and very important concept is finding the solution of a system of linear equations using matrix method. Once if you know the inverse of a matrix, then you can easily solve any equation, simultaneous equations using matrix method that we are going to discuss today. First, let us discuss regarding how to find the inverse. Now, let us know regarding inverse of a square matrix. So, a square matrix A is invertible if and only if A is a non-singular matrix. So, if it is a non-singular matrix, then only the inverse exists. Non-singular means what? The determinant of A is not equal to 0. So, if determinant A is not equal to 0, then only the inverse exists. So, the inverse, a square matrix A is invertible if and only if A is a singular matrix. So, therefore, the A inverse is given by A inverse is equal to 1 over determinant of A into adjoint of A, or A inverse is equal to adjoint of A divided by its determinant. So, therefore, A inverse is always given by 1 over determinant of A into adjoint of A. That is why this A should not be equal to 0. If it is 0, if it is not defined, you will get infinite number. So, therefore, inverse exists if and only if A is a non-singular matrix. So, the inverse is given by adjoint of a matrix divided by its determinant. So, adjoint, as you know, the adjoint, how to find the adjoint? Transpose of the cofactor matrix. So, transpose of the cofactor matrix will give the adjoint. If you divide the adjoint of a matrix divided by its own inverse, then its own determinant, then you are going to get the inverse of a matrix. So, in general, A inverse is given by 1 over determinant of A into adjoint of A. Now, let us take a problem based on 2 rows and 2 columns. Now, let us take a small example. Find the inverse of A. What is given? 3, 2, 1, minus 1. Let us find out the determinant of A. Check whether it is a singular or non-singular matrix. Determinant of A is equal to determinant 3, 2, 1, minus 1. Simplify this. 3 1s are 3, minus 1 2s are 2. This is equal to minus 5. So, determinant of A is equal to minus 5, not equal to 0. Therefore, A inverse exists. Let us take a first problem. Let us take an example. Find the inverse of A. A is equal to 3, 1, minus 1. Now, first find out the determinant of A. So, determinant of A is 3, 2, 1, minus 1. So, its value 3 1s are 3, minus 1 into 2 is 2. This is equal to minus 5, not equal to 0. So, therefore, determinant of A is equal to minus 5. Therefore, A inverse exists. So, A inverse exists. Now, find what is the A formula for A inverse. So, A inverse is equal to 1 over determinant of A into adjoint of A. 1 over determinant A. Now, find out the adjoint of A first. Now, as you know, for 2 rows 2 column, how to find the adjoint? So, adjoint is nothing but interchanging the diagonals. So, 3 minus 1 can be written as minus 1 and 3. And changing the sign, so plus 2 becomes minus 2 and plus 1 becomes minus 1. So this is the adjoint. Now therefore A inverse is equal to 1 over determinant of A is minus 5 into minus 1, minus 2, minus 1 and 3. So this is the value of A inverse. So the A inverse of the square matrix is given by A inverse is equal to, you can also write minus 1 by 5, minus 1 over 5 into minus 1, minus 2, minus 1 and 3, or if you want, you can also take minus common factor. So that is minus into minus become plus, 1 by 5 into 1 by 2, 1, 2, 1 and minus 3, as you wish. So that is how we are going to find the inverse of 2 rows and 2 columns. Let me take one more problem. It's a very simple concept. So let us take, find the inverse of B is equal to, now let us write down the determinant of B. B is equal to minus 1, 5, 0, minus 2. This is, simplify this, minus 1 into 2, minus 2 is minus into minus plus 2, 0 into 5 is 0, this is equal to 2. So therefore, determinant of B is equal to 2, not equal to 0. So B inverse exists. B inverse exists. Now find out the adjoint of B. Adjoint of B is equal to, interchanging the diagonals, 1 minus 2 can be written as minus 2 minus 1 and plus 5 becomes minus 5, and this is minus 0 is nothing but 0. Now therefore B inverse is equal to 1 over determinant of B into adjoint of B. This is 1 over determinant of B is 2 into, what is the adjoint? Minus 2, minus 5, 0 and minus 1. This is the required inverse. So see here, find the inverse of B. B is equal to minus 1, 5, 0, minus 2. Find out the determinant. That determinant of B is equal to minus into minus plus 1 to 2, minus 0 into 5 is 0, 2 minus 0 is equal to 0. Therefore, determinant of B is equal to 2. So, this is not equal to 0. Inverse exists. Now, find out the adjoint. Adjoint of B is equal to, interchanging the diagonals. Minus 1, minus 2 can be written as minus 2, minus 1. And changing the signs for secondary diagonal, minus 5 and plus 0. So therefore B inverse is equal to 1 over determinant of B into adjoint of B. So 1 over B, what is B? 2. So 1 over 2 into adjoint of B is minus 2, minus 5, 0 and minus 1. This is very simple. So you may get one question to find A inverse. You can easily solve. Okay. Let us come to the next problem. Let us take this problem. If A is equal to 2, 3, 1, minus 1, and this is B, not A, this is B is equal to 1, minus 2, minus 1, 3, then verify that AB inverse is equal to B inverse, A inverse. Now first find out AB. AB is equal to, what is A? 2, 3, 1, minus 4 into B, 1, minus 2, minus 1, 3. Multiply this, matrix multiplication. First row, first column, second column. So 2 ones are 2, minus 3 ones are 3. Again 2 into minus 2 is minus 4, plus 3 3s are 9. Again second row, first column, second column. 1 into 1 is 1, minus into minus plus, 1 4s are 4. Again second row, last column, 1 into minus 2 is minus 2, minus 4 3s are 12. So this is equal to 2 minus 3 is minus 1, 9 minus 4 is plus 5. Again 1 plus 4 is equal to plus 5, minus 12 minus 2 is minus 14. Okay, now just find out the determinant of AB. Now determinant of AB is equal to determinant minus 1, 5, 5, minus 14, minus into minus plus 14, minus 5 5s are 25. This is equal to minus 11. So determinant of AB is equal to minus 11, not equal to 0. Therefore AB inverse exists. You know, inverse of A is, A inverse is equal to 1 over determinant of A into adjoint of A. Similarly, B inverse is 1 over determinant B into adjoint of B. If it is AB means AB inverse is equal to 1 over determinant AB into adjoint of AB. So AB inverse is nothing but 1 over determinant of AB into adjoint of AB. Now straight away I will write the adjoint. 1 over determinant of AB is minus 1 over 11 into, write down the adjoint of AB. Interchanging the diagonals for AB. Interchange this, minus 1 minus 14 can be written as minus 14 and minus 1. And changing the signs for this is minus 5 and minus 5. Let us represent this as equation number 1. Minus 1 over 11, minus 14, minus 5 and minus 1. This is inverse of AB. AB inverse. Now, let us find out the inverse of B and inverse of A. Okay, hope you are understand. You followed this. So first find out AB inverse. This is AB inverse. Now let us come to the next part. AB inverse is equal to minus 1 over 11 into, or if you want you can multiply by negative sign. Minus into minus it becomes plus. All elements are multiplied by negative. This becomes plus 14 plus 5 again plus 5 and plus 1. Let us represent this as equation number 1. Come to the second part. Now, first find out determinant of A. Determinant of A is equal to 2, 3, 1, minus 4. So, this is 2 4s are 8, minus 8, 1 3s are 3. This is equal to minus 11, not equal to 0. So, inverse exists. Next, determinant of B. Now, this is minus 8 minus 3 is equal to minus 11, not equal to 0. So, therefore, A inverse exists. Determinant of B. Determinant of B is 1, minus 2, minus 1 and 3. This is 1, 3s are 3. Minus into minus, plus into minus, minus 1, 2s are 2. This is 1. This is also not equal to 0. Now, write down the inverse of A and B. Now, A inverse is equal to 1 over determinant A is minus 11 into adjoint of A. I will straight away write the adjoint for this. 2, 4 can be written as minus 4 and 2. And changing the diagonals, this is minus 3 and minus 1. Now, come to this B inverse. 1 over 1 into adjoint of B. Interchange the diagonals 3 and 1. This can be written as plus 2 and plus 1. Now, therefore, now let us come to the right hand side. RHS B inverse A inverse. B inverse into A inverse. B is, this is, I can take minus 1 by 11 out into B first. 3, 2, 1, 1 into A inverse. Minus 4, minus 3, minus 1 and 2. Multiply. So, if you get the same answer, then it is correct. Minus 1 over 11 into 3 4s are 12, minus 12, minus 2 1s are 2, 3 3s are 9, minus 9, plus 2 2s are 4. Again, 1 4s are 4, minus 4, plus 1 into minus 1 is minus 1, 1 into minus 3 is minus 3, plus 2, 1 into 2 is 2. So, this is minus 1 over 11 times minus 12, minus 2 is minus 14, minus 9 plus 5 is minus 5. Again, this is equal to minus 5 and this is minus 1. So, you can also write it as B inverse A inverse is equal to multiply by negative sign. Then this becomes 1 over 11 into plus 14 plus 5 plus 5 plus 1. This is equation number 2. See from equation number 1 and 2. B inverse A inverse 1 over 11 into 14 5 5 1. This is equation number 1. This is equation number 2. So, therefore, from 1 and 2, you can write from 1 and 2, you can say that AB whole inverse is equal to B inverse into A inverse. This is important problem. This is called a reversal law of inverses. First find out AB and adjoint of AB and inverse of AB. Then find inverse of A and inverse of B, multiply B inverse and A inverse. LHS is equal to RHS. Very simple problem. Okay. Hope you understood this. So, hope you are following this. Very simple concept. Now, let us come to a problem. How to find 3 rows 3 column matrix inverse. So, how to find the inverse of 3 rows 3 column matrix. Now, come to this problem. Find the inverse of A is equal to 1 1 2 3 minus 1 2 minus 1 1 and 9 and 3. So, once if you know how to find the inverse of 3 rows and 3 columns, easily you can solve the problems on simultaneous equations. So, that will purchase around 6 marks. So, easily you will get 6 marks once you know the inverse. Now, let us write down the adjoint. First, write down the determinant of A. Determinant of this is 1 1 2 3 minus 1 2 minus 1 1 and 3. This is plus minus and plus 1 into, simplify this, minus 3 minus 2 minus 1 into, delete this, 3 3s are 9, minus into minus plus 2 into, this row column is gone, 3 1s are 3, minus into minus plus into minus minus. So, that is equal to 1 into minus 5 minus 1 into 11 plus 2 into 2. So, this is equal to minus 5 minus 11 plus 4. So minus 5 minus 11 is minus 16 plus 4. This is equal to minus 12. So determinant of A is equal to minus 12 not equal to 0. Therefore, A inverse exists. Just go on writing the cofactors. So that I explained in the previous class. Now write down the signs for this. Plus minus plus plus minus plus minus plus minus plus minus and plus. The diagonals are positive. Write down the cofactors. Cofactor of first element 1 is equal to, delete the row and column containing this, minus 1 into 3 is minus 3 minus 2, this is equal to minus 5, first element. Similarly, cofactor of second element plus 1 is, the sign is minus, so this row and column is deleted, 3 3s are 9, minus into minus plus, 1 2s are 2, that's equal to minus 11. Similarly, cofactor of next element is plus 2. It is positive. This row and column is gone. 3 1s are 3. Minus into minus plus into minus minus, that's equal to 2. So for the first row, you are going to get the cofactors. So cofactors are minus 5, minus 11 and 2. Let me write here the cofactors for first row. Similarly, for the second row, cofactor of 3, it is negative, minus this, delete the row and column containing 3, this is gone, 1 3s are 3 minus 2, 3 minus 2, this is equal to minus 1. Cofactor of minus 1 is equal to, this row and column is deleted, 1 3s are 3 plus 1 2s are 2, this is equal to 5. So cofactor of next element 2, cofactor of 2 is equal to, the sign is negative, it is negative, this row and column is deleted, 1 1s are 1 plus 1, 1 plus 1, this is equal to minus 2. So the cofactors I am going to write here, minus 1, 5 and minus 2. Similarly, for the last row, the cofactor of minus 1. So this row and column is deleted, 1 2s are 2, minus into minus plus, that's equal to 4. Again, cofactor of plus 1, it is minus, this row and column is deleted, 1 2s are 2 minus 6, that's equal to minus of minus is plus 4. And the last element, cofactor of 3 is equal to, this row and column is deleted, 1 into minus 1 is minus 1, minus 3 1s are 3, that's equal to minus 4. So I will write the cofactors. So these are 4 plus 4 and minus 4. Okay. Now these are the cofactors. Now what is the determinant of A? Determinant of A is equal to minus 12. And these are the cofactors. So the cofactor matrix is, this is the cofactor matrix. Since determinant of A is equal to minus 12, now therefore adjoint of A is equal to adjoint of A, transpose this, that is minus 5, minus 11 and 2, this is minus 1, 5, minus 2, 4, 4, minus 4. Now therefore A inverse is equal to 1 over determinant of A into adjoint of A. Now what is A inverse? A inverse is equal to 1 over determinant of A into adjoint of A. 1 over determinant of A is minus 1 over 12 into adjoint of A. Adjoint of A is this one, minus 5, minus 1 and 4 matrix, minus 11, 5 and 4, then 2, minus 2 and minus 4. So minus 5, minus 1, 4, minus 11, this is 5, 4, 2, minus 2, minus. So this is the value of A inverse. So A inverse is equal to 1 over determinant of A into adjoint of A. Usually you may expect this for 3 marks or definitely a 6 marks question from simultaneous equation. Now let us come to the simultaneous equation. One of the application of matrices and determinants are finding the solution of a linear system of equations using matrix method. There are two methods. One is the Cramer's method, determinant method, that is called Cramer's rule. Another method is called the matrix method. Let me take first matrix method, then I will teach the Cramer's rule. Now applications of matrices and determinants, matrix determinants and matrices. Now, so to find the solution of a linear system of equation using matrix method, to find the solution of a system of linear equations using matrix method, so that is by using To solve the linear system of equations using matrix method by knowing the inverse, and that is called the matrix method. To solve the system of linear equations using inverse by matrix method. Using inverse, we are going to solve the system of equation. That method is called the matrix method. Now consider, I will explain the general method. The general method, consider the system of linear equation. Let us consider three equations. A1x plus b1y plus c1z is equal to d1, a2x plus b2y plus c2z is equal to d2, and a3x plus b3y plus c3z is equal to d3. Let us consider three simultaneous equations. Now what is to solve is to find the value of x, y and z. Now very simple method. The method is like this. I will write down the method, then we will solve the problem. First check whether it is in order or not. X, y, z constant, x, y, z constant, x, y, z constant. First point. Next, find out the coefficient. Let us represent A is equal to the coefficients of x, y and z. Coefficient of x is a1, a2, a3. Coefficient of y are b1, b2, b3. Coefficient of z are c1, c2 and c3. Write down the coefficients of x, y and z. Next, x, matrix x is equal to, this is to be determined, x, y and z. What is x? X, y and z. And the constant matrix B is equal to constant elements d1, d2 and d3. d1, d2 and d3. That's all. First write down A, coefficient of x, y and z. X in the first column, y in the second column, z in the third column. Then x is nothing but x, y, z, first column, and the constant matrix d1, d2, d3 as B. The solution is given by, this is the formula, very important formula. The solution is x is equal to A inverse into B. This is the solution. X is equal to A inverse into B. What is the solution? The solution is given by x is equal to A inverse into B. So find out the inverse for this matrix and multiply with this constant matrix, then you will get x, y, z. So therefore, what is x here? X, y, z is equal to A inverse into B. X, y, z is equal to A inverse into B. This is for a simultaneous equations of three variables, x, y, z. If it is two variables like x and y, you will get two rows, two columns. That's very easy. Let me start with simultaneous equations of x and y, then x, y and z. Let me take two rows, two columns, then three rows, three columns. Now, this is the method. So, what is the general method? Write down the coefficients of x, y, z. Consider it as matrix A. Matrix A is equal to coefficient of x, y, z, a1, a2, a3, b1, b2, b3, c1, c2, c3, and x is equal to x, y, z, first column, and B is equal to the constant matrix d1, d2 and d3. The solution is given by x is equal to A inverse into B. So, x, y, z is equal to A inverse B. So, find out the inverse for A using the adjoint, then multiply with constant matrix, we will get the solution. Let us take a problem. Let me start with easy problem. So, this is the solution. See, A is equal to A1, B1, A1, A2, A3, B1, B2, B3, C1, C2, C3, x is equal to x, y, z, B is equal to D. So, the solution is given by x is equal to A inverse of B, where A inverse is equal to 1 over determinant of into adjoint of A. So, the solution, what is the solution? X is equal to A inverse into B. What is x? X is nothing but x, y, z is equal to A inverse into B, where A inverse is equal to A inverse is 1 over determinant of A into adjoint of A. This is the method to solve. This is how we are going to solve. Let me take an example. Solve the system of equation 2x plus 5y is equal to 1 and 3x plus 2y is equal to 7 using matrix method. Don't get confused. This is matrix method. One more method is there, that is called Cramer's rule, that is determinant method. This is matrix method, that is determinant method, that I will explain in the next class. Let us check what is the equation given. 2x plus 5y is equal to 1. This is in order. And the second equation 3x plus 2y is equal to 7. Now, just write down A. A is nothing but, as I told you, coefficient of x and y. Coefficient of x is 2 and 3. Here the coefficient of y are 5 and 2. And you know x is equal to x, y, and B is equal to the constant matrix 1 and 7. What is the solution? The solution is x is equal to A inverse into B. Now first find out the inverse of A. For that, write down the determinant. Determinant of A is equal to 2, 5, 3, 2. So this is equal to 2 2s are 4 minus 5 3s are 15. This is equal to minus 11. Write down the adjoint of A. Now adjoint of A is equal to, interchanging the diagonals, this is 2 remains the same, minus 5 and minus 3. Interchanging the diagonals, plus 2 remains the same, and changing the signs, plus 5 becomes minus 5 and plus 3 becomes minus 3. Now therefore A inverse is equal to, what is the formula? 1 over determinant of A into adjoint of A. This is minus 1 over determinant of A is 11 into adjoint of A is 2, minus 3, minus 5 and 2. Now what is the formula for solution? X is equal to, x is x, y is equal to A inverse into B. This is the solution. X is xy. What is A inverse? Minus 1 over 11 into 2 minus 5 minus 3 into 2 into B. What is B? Matrix B is nothing but 1 and 7. Now multiply this, matrix multiplication. That's it. So minus 1 over 11 into 2 ones are 2 minus 7 5s are 35. Next, minus 1 into 3 is minus 3 plus 2 7s are 14. So this is minus 1 over 11 into 35 minus 2 is minus 33, and 14 minus 3 is equal to 11. So if you divide, so what you are going to get? Minus 1 over 11 into minus 33 and 11 divided by 11, minus into minus plus, 33 by 11 is 3 and 11 by 11 is equal to 1. So therefore x is equal to 3 and y is equal to 1. If you want, you can verify. Substitute here, take this equation, 3x plus 2y is equal to 7, 3 into, yes, 3 into x, this is minus 1. So 3 into x is 3 plus 2 into y is minus 1. So 3 3s are 9 minus 2, 7 is equal to 7. This is 3. Right. So verification. If you want, you can verify. So therefore the solution is x is equal to 3 and y is equal to minus 1. This is how we are going to solve system of equation of two variables x and y. So first write down A, coefficient of x and y, then x, y, the constant 1 and 7, x is equal to A inverse B. Find the inverse for A, just adjoint of A. Determinant of A is minus 11, adjoint is 2 minus 5 minus 3, 2, and A inverse is 1 over determinant of A into adjoint of A. So on the solution, x is equal to A inverse B, A inverse into B, multiply it, first row first column, second row first column, you will get minus 33, 11, divide it, so 3 and minus, so x is equal to 3 and y is equal to minus 1. That is the solution, very easiest method. Okay, hope you are following. Let me take one more problem, I will explain. Take this, the system of equations, solve the system of equations x plus y is equal to 3 and 3x minus 2y is equal to 1 using matrix method. Let me solve this. So x plus y is equal to 3, 3x minus 2y is equal to 1. So this is in order. Okay, now write down the values of A. Here A is nothing but the coefficient of x. What is the coefficient of x? 1, 3. Y 1 minus 2. Then x is equal, as you know, x is equal to x and y. What is B? B is the constant matrix, that is 3 and 1. Now find out the value of determinant of A. Determinant of A is equal to determinant 1, 1, 3 minus 2. This is equal to 1, 2 is 2, minus 2, minus 3. That's equal to minus 5, not equal to 0. Okay, therefore the solution is x is equal to A inverse into B. Now find out the inverse for A. For this inverse of A, determinant is known, adjoint of A. Adjoint of A is equal to, interchange the diagonal, 1 and minus 2 can be written as minus 2 and 1, and this is minus 1 and minus 3. So therefore A inverse is equal to 1 over determinant of A into adjoint of A. So this is 1 over determinant is minus 5. 1 over 5 into adjoint of A is minus 2, minus 3, minus 1 and plus 1. Now the solution is x is equal to A inverse into B. What is x? X is nothing but x and y. A inverse is minus 1 over minus 2, minus 3, minus 1, 1 into B. What is B? B is 3 and 1. Simplify this. Minus 1 over 5 into first row first column minus 2 3s are 6 minus 1 1s are 1. Again minus 3 3s are 9 plus 1. So this is equal to minus 1 over 5 times minus 7 minus 8. So if it is possible to divide it. So you can't divide this. So therefore x and y is equal to multiply by minus into minus plus 7 by 5 and minus into minus plus 8 by 5. So x is equal to 7 by 5, y is equal to 8 by 5. These are the values. That is how we are going to solve 2 rows 2 column. That is simultaneous equations of two variables x and y. So x plus y is equal to 3, 3x minus 2y is equal to 1. Write down A 1 1 3 minus 2 x and constant matrix 3 and 1. Write down the determinant. 1 into minus 2 is minus 2 minus 3, that's equal to minus 5, not equal to 0. Inverse exists. Write down the adjoint of A. Adjoint of A is equal to 1 minus 2 can be minus 2 and plus 1. This is minus 1 and minus 3. A inverse is equal to 1 over determinant of A into adjoint of A. 1 over minus 1 over 5 into minus 2 minus 1 minus 3. So the solution x is equal to A inverse B. A inverse minus 1 over 5 into minus 2 minus 1 minus 3 1 into B is 3 and 1. This is multiply minus 2 3s are 6 minus into plus minus 1 minus 3 3s are 9 plus 1 minus 6 minus 1 is minus 7 minus 9 plus 1 is minus 8 minus into minus plus 7 by 5 minus into minus plus 8 by 5. So therefore x is equal to 7 by 5 plus 8 by 5. That is the simplified answer. If you want to verify, you can verify here. See, x plus y. What is x plus y? 3. 7 by 5, 8 by 5. 7 plus 8 is 15. 15 by 5 is equal to 3. You will get the answer. The answer is correct. So this is how we are going to solve a simultaneous equations of two variables. Okay. So this is how we are going to solve a simultaneous equations of two variables. So in the next session, I am going to discuss regarding simultaneous equations of three variables x, y and z. That is very important for the point of examination. Definitely you will get one 6-mark question of 3 rows and 3 columns. That is to solve the simultaneous equations which contains x, y and z terms. So let's meet in the next class. Thank you. Thank you very much.